So today we're going to do a deep dive into something maybe a bit behind the scenes, the tech that makes those really cool commercial displays work. Specifically, we're looking at the A-Neuvideo 4K video wall rotation processor. It's kind of the unsung hero behind those rotated or creatively arranged screens you see.
Exactly. It's a very specialized piece of kit.
Yeah.
And our goal here is really to figure out how this one device manages, complex 4K video rotation, scaling, all without noticeable lag or, well, problems.
Right, because the specs are pretty solid. It handles up to 4K resolution at 60 Hz, 18 GBps bandwidth. It's got 2 HDMI inputs, 1 HDMI output. On paper, maybe sounds straightforward, but the processing needed for this kind of manipulation, that's got to be pretty intense. Okay, let's unpack this.
It really is. And that core processing happens in what the specs call warping mode. This is really where the magic happens, taking the input signal and precisely scaling and rotating it. Think about displays mounted vertically or maybe at like a weird angle for an art installation. This mode handles that.
And it's really fine control, isn't it? 360-degree rotation, but adjustable in just 1-degree steps. But hang on, why can't, a regular computer or just some software handle that? Why the need for this dedicated box?
That's the key question. It really boils down to speed, latency. This processor keeps the video lag incredibly low. We're talking only 1-2 frames. That's almost instant.
1 to 2 frames.
Yeah. So if you're in, say, control room, maybe security monitoring, where you need immediate visual feedback, you just can't have the delay that software solutions often introduce.
Got it. So it's not just about turning the picture, it's about turning it now. And the source material mentioned if you want to go really big, like for advertising.
Right. You can actually sync multiple units, use a splitter or a matrix switcher, and you can build these huge, pretty impressive video walls. Eye-catching stuff.
Okay, so warping handles the rotation and speed, but what about managing different video sources or layouts on maybe just one screen?
A good point. That takes us to the other main function, the scaling mode. This adds another layer of flexibility.
And this lets you scale the output to lots of different resolutions, right? Up to that 4K 60 maximum. But it also does multi-windowing.
Exactly. It supports up to 2 simultaneous picture-in-picture windows pi-p, And these windows are freely scalable. You can place them wherever you need.
Oh, interesting. So you could have like a main feed and a smaller secondary feed.
Precisely. And they even included details like letting you add colored borders around those pi-p windows. It sounds small, but for visual clarity, especially in like a command center, that kind of detail matters.
Makes sense. How do you actually set all this up, though? Seems like it could get complicated quickly.
Well, they've tried to simplify it. There's a dedicated video wall PC application. It uses a graphical interface, WYSIWG. What you see is what you get.
Ah, the drag and drop approach. So you're visually arranging the windows on a virtual screen.
Exactly that. You click, you drag, you see this result immediately. Much easier than punching in coordinates. It even has presets for common arrangements. And besides the PC app, you can also control it through the on-screen display menu or Telnet or RS-232 for more integrated systems.
So quite a few options. It sounds like it makes complex setups more accessible, not just for programming wizards.
It really does. If we connect this to the bigger picture, this kind of control interface helps bring sophisticated display design capabilities out to, AV installers in the field.
Okay, so features are solid. What about the professional side, like compliance and reliability?
Yeah, it ticks those boxes too. It's HDCP compliant versions 1.x and 2.2, so it handles protected content from different sources. And crucially, it's TAA compliant.
TAA compliant. That's for Government Procurement, right? Trade Agreements Act.
That's the one. It's a requirement for U.S. federal government purchasing. So this device is cleared for use in secure environments, government control rooms, defense applications, places where that compliance is absolutely non-negotiable.
Plus, it seems built tough, mentions a metal or steel chassis, and it comes with a 3-year warranty. Okay, here's where it gets really interesting for me. You've got this TAA compliance, which implies, security and rigorous standards, but you also have that incredibly low 1 to 2 frame latency while doing heavy 4K rotation.
That combination is quite an engineering feat. Achieving that sweet spot of security, robustness, and real-time speed isn't trivial.
Definitely not. So the big takeaway seems to be the sheer power density.
I think so. You have this, 2-pound box, maybe 945 grams, a small thing, really, but it's the dedicated, powerful engine driving these huge, dynamic, creative visuals we see out in the world.
It's the hidden workhorse behind those massive, maybe rotated 4K displays you walk past downtown or see in Mission Control.
Exactly. And maybe here's a final thought to leave you with. Think about that contrast.
This small, very specific component, controlling these enormous high-resolution visual environments. So next time you see a really complex digital display system, could be a stadium scoreboard, an airport information system, a traffic control center, just maybe pause and wonder, what other tiny, specialized, powerful pieces of tech like this are making the whole thing possible? What's hiding just out of sight?